The exponent determines the domain in this case. And I notice that the exponent is x squared, and the domain of x squared is all real numbers. So that says that is what the domain is. Three to this thing. Now in this case, the exponent is x minus 3 over x plus 5. Well, that's a rational function. So we know that the denominator can't be 0. So x plus 5 can't be 0. So it's all real numbers. X can't be negative 5. So that's what your domain would be. So it's going to be the exponent on the exponential that's going to determine whether or not the domain is all real numbers. Logarithm we know has a domain issue. And we know that the argument must be positive. X minus 1 must be positive. X must be greater than 1. So that's what his domain is. And that becomes important when we move into 4.6 and we start solving equations. Now here, again, the argument must be positive. X squared minus 9 must be positive. Now, if you use the inequality, you're more than likely going to lose half of your answer. It's the nature of the creature. If you're doing a linear, it's fine because you don't have a problem. But if you're doing something other than a linear, you need to go into the equal, which says that x squared minus 9 equals 0. Now, what we know about x squared minus 9, our basic function is x squared. He's moved down 9 units. So that's a transformation. That's what he looks like. I want this guy to be positive. So from the graph point of view, where is he positive? He's positive on the outside arms. He's negative in the middle, right? So that's what this should show up. If you use the inequality, you're going to reject the negative, and then essentially what happens is you're not going to realize that this thing has to flip, is what it amounts to. Yes?
Are you shifting the graph to the right?
No, I'm shifting him down because it's minus 9. It's x squared, right? And then it's down 9 units. Yeah. Now, if I had this instead, that's your right. Yeah. That's your right. So we know that x squared equals 9, or x equals plus or minus 3. So number line, minus 3, plus 3. If I pull my test point, x equals 0. At 0, it's negative, positive, positive. There's your domain right there. You can see it matches the graph above. It's on the outside. So your domain is minus infinity, negative 3, 3, infinity. Or x greater than 3, x less than negative 3. And that's the thing, if you're doing the inequality, when I learned this stuff, that was 2 cases. I had to do 2 cases. one where x minus 9 was greater than 0 and one where x minus 9 was, well, no, it's a, well, anyway, I had to do both sides. It's been so long. But I had to divide it up into two pieces. And I can think of one thing, but that's not exactly how we did cases. Now the question is, can these two things be written to the same base? Well, 3 is prime, is 81. Well, if I go to my table, I notice that 81 is 3 to the 4th power. So this becomes 1/3 to the x minus 5 equals 1/3 to the 4th. So that x minus 5 equals 4 because the bases are the same, or x equals 9. Right now the practice is on writing things to the same base. Can 8 and 4 be written to the same base? The answer is yes, to 2. This is 2 cubed to the 2x plus 1 equals 2 squared to the 6x. Or 2, now using the properties of exponents we talked about yesterday, that a to the m to the n power is a to the m times n. This is 2 to the 3 times 2x plus 1 equals 2 to the 2 times 6x. The bases are now the same, so the exponents are equal. 3 to the 2x plus 1 equals 2 times 6x, you could say 12x. 6x plus 3, now look at that, I almost did it. 6x plus 3 equals 12x. Subtract 6x from both sides, I get 3 is equal to, subtract 6, 6x, or x is equal to 3 divided by 6, so x is 1 divided by 2. Any questions? Log equation. So this says that 2 to the 3 equals x squared minus 1. X squared minus 1 equals 8. X squared equals 9, or x is plus or minus the square root of 9, which is plus or minus 3. Now remember, log has a domain issue. So I need to make sure it doesn't make the argument negative. Now I can tell it doesn't, because what's x? What am I doing to the x value? Squaring it. Because a negative squared would be positive, and a positive squared would be positive. So will plus and minus 3 both work? Yes. But remember, check your answers. The argument must be positive. And we did do a semi-check. So that works. Any questions?
So you'd just be using your number line to check that argument?
Well, no, remember the argument has to be positive, so that means x squared minus 1 has to be positive, right? You can use the number line if you wanted to, but if I look at x equal negative 3, then negative 3 squared minus 1 is a positive number, right? And 3 squared minus 1 is also a positive number. So it doesn't make the argument negative. Here's what happens, and this happens all the time in mathematics, is that this guy has a domain issue. Because x squared minus 1 has to be positive. So day 1, right? Then I rewrite, and the problem I've solved, this guy has no domain issue. So as a result, I can come up with an answer that doesn't work in the original problem. That's why you have to check your answers. Because when I made the rewrite, I am assuming, the assumption I made when I rewrite, and I don't think about that assumption, the assumption I make when I rewrite that thing is that that's going to be a positive thing. I learned that the hard way. I was teaching a calculus class at ASU, and I don't know whether it was like my evening class or what have you, and I was working a problem alone. I think it was and I did something, and one of the students said, "When you did that, aren't you assuming?" As I came up with an answer. When you did that, aren't you assuming such and such, such and such, such and such? Well, when I look back at the original problem, was like, yeah, when I divided by something, I'm assuming that. And when you see that as this guy, suppose what I have is that x plus 3 over x minus 1 equals 2 over x. The original problem says that x can't be 0, x can't be 1, because I can't divide by 0. Right? Well, I'm going to multiply both sides by the common denominator, which kills the denominator. But when I do that, I am assuming that x can't be 0 and x can't be 1. That's the assumption I'm making when I actually do that process. Because when I do that, I come down with x times x plus 3 equals 2 times x minus 1. What is the domain here? No denominator, no radical. No log. The domain here is all real numbers. Can I introduce an answer of x equals 0 and x equal 1? Yes, because the domain here is all real numbers. But when I did that multiplication, this is what I assume. And it took a student at ASU kind of saying, did you assume? You assumed when you did such and such and such and such that x could not be. And I'm thinking, yeah, you're right. And that's been a long time ago, and the interesting thing is, I remember that incident like it happened yesterday.